Good evening, this is Bryce Hall, and this is my lesson plan on pill design. The focus is geometry, but I have created it for an integrated Math 1 class, which covers mainly geometry and what used to be known as Algebra 1. So the way I made this lesson was from the Second Opinion Linked Learning document. It was originally a 100-minute lesson, as you can see right here. So I broke this lesson up into 2 days of two 50-minute lessons. It covers grade level 9, and here we go. The essential literacy strategy focus was to discuss possible considerations when designing the shape of a medicine pill as related to surface area and volume. The related skills that go along with that is the student's ability to calculate surface area and volume of prisms, cylinders, etc., different three-dimensional shapes, and then determine the ratio of surface area to volume. The content focus is we're using real-life scenarios to understand the different applications and uses of geometry. Here are 3 standards that covered from the Common Core, which are basically known formulas of volume and surface area of different three-dimensional objects, shapes, and apply geometric methods to solve given real-life scenarios, and then, of course, for the students to learn, compute, and memorize those different formulas. The instructional learning objectives are basically straight from the document. It is to determine the surface area and volume of prisms, cylinders, and figures made up of different prisms and cylinders, and determine how quickly a particular medication or in a certain shape might be absorbed by the body given its surface area to volume ratio. The assessments in this lesson mainly consist of the planning a pill worksheet that they'll fill out, in which they demonstrate their understanding and then create graphs and written explanations to show the absorption over time in relation to that previous mentioned surface to area volume ratio. The language functions are discuss possible considerations when designing the shape of a medicine pill as related to surface area and volume, and explain how that ratio affects the absorption of a pill. The main vocabulary is volume, surface area, cylinder, prism, ratio, and absorption rate. And the resources and materials, again, are basically pulled straight from the document. They'll need pencil, paper, the actual article that we're reading, construction paper, scissors, tape, examples of different pills that I would bring in. We don't need students running around with jugs at school. But small grains, beans, or cereal, and a large measurement beaker, as well as the planning a pill worksheet that comes with the document. The prior knowledge they should have is the ability to define area of polygons, circles in different shapes, and they should be familiar at least with some of the three-dimensional objects that we'll be looking at in this lesson. Transition, our previous lesson was to review dimensions and area of two-dimensional shapes, and again introduce and go over some of the more complex three-dimensional shapes. The hook in this scenario is to let the students know that scientists actually use this information and methods and as it is a real-life scenario. And then we'd start by asking the students to volunteer descriptions of shapes of different pills they have encountered and what are some of the reasons that they might be able to come up with for the similarities and differences between those pills and shapes. For focused instruction, we'd first start out by defining surface area and volume, and then define some of the different shapes, show some examples, and for the struggling students, I would probably give a little bit more detail in some of the examples, show the specific dimensions as in base, height, width, etc., and show how and what the volume or surface area would be. For the guided instruction practice, again, that comes pretty much straight out of the document, and that's the main focus, where students are divided up into groups and are given tape, scissors, and construction paper to come up with their own sort of ideal shape for a pill, whether we want it to be absorbed really fast or something that needs to be bigger but absorbed slower. And the idea is it better to have a bigger volume or bigger surface area or both? And that's kind of the point of that activity. For that, differentiating and scaffolding, I would walk around and help the groups that struggle by possibly pointing out different shapes and potential shapes they could use that differ in a volume to surface area ratio. And for the gifted students, I would challenge them to determine shapes that maximize the surface area compared to volume, and vice versa. For the independent practice, they will, after creating their shapes, fill out the pill planning worksheet and work in groups, and then finish it at home to go over the stats, see what different shapes and sizes create the different ratios, and which would be dissolved faster, which would be dissolved slower, etc. And for the differentiating scaffold on that one, with this class, we do have some students that struggle, a lot of IEPs and English language learners, so I would probably go through, as my guide teacher has done before, and set up some tables on their worksheet. A lot of times he goes through, and when there's a question that might be a little bit more complex, we'll start to write out the answer to the question and then kind of create it in a way that it's a fill in the blank. So they just kind of put a skeleton of the answer, but then the student has to fill in the important blanks to get the answer to that question. And for the closure, we would go over a few common misconceptions that students have. For example, a lot of times students tend to think that surface area, the greater the surface area, the greater the volume, which is not necessarily the case, because different shapes, you can have a small volume, but a larger surface area, etc. So I think this was a great lesson, and this document we used is a great document to plan a lesson off of. So yeah, hope this video wasn't too long, but there is my lesson on planning a pill design.